We all know that climate change is a huge problem and we have to act now in order to save our planet's future. This means we have to change everything we do, from the energy and transport systems that we use to the way we think about agriculture and the food industry. It's not enough to have access to better and greener technology, such as the fantastic innovation of electric vehicles. We also have to enable their usage. Are we going to reduce tax on them? Are we going to provide owners with free parking? And are we going to standardize the charging infrastructure? These are many decisions have to be made at the regulatory level. Fortunately, there are already thousands of laws and policies put into place by hundreds of nations across the globe that affect climate change. These typically contain targets. Targets are goals and commitments in the fight against climate change, such as the UK committing to net zero greenhouse gas emissions by 2050. Hi, my name's Ryan Hannam, and for the last 6 weeks, I've been working with Climate Policy Radar to use machine learning to automatically identify targets within policy documents. Climate Policy Radar are a not-for-profit startup building the evidence base and tools to make data-formed decision-making in the climate space possible. So why do we care so much about targets? Well, targets allow us to track progress and ambition of individual nations and their governments. We can hold governments accountable when they deviate from the course. And they allow us to redirect investment and energy to the places which will have the highest impact. The data I had access to was thousands of policy documents, and these range from laws and legislations to strategies and plans, and they were typically 20 to hundreds of pages long, many containing a handful of targets. So this is really a needle in a haystack kind of problem. Fortunately, I also had access to human summaries of targets within these documents written by policy experts. So by combining the two data sets, I was able to create a structured data set of individual sentences labeled as targets or not. The way I did this was using a technique called natural language processing. NLP is an area of machine learning that looks to analyze text and speech for patterns. I used NLP to extract individual sentences from all these policy documents and label them as potential targets. This was done by converting the sentences into numerical representations, which preserve important features of the sentences, such as grammar and word order. And then by comparing the numerical features to those of the summaries, we can tell whether or not a target is similar because they will have similar numerical features. These numerical features also preserve important information around meaning, such as the phrase climate investment. Just swapping the word order there to investment climate dramatically changes the meaning. So how did my models perform on these numerical features? Well, simple machine learning models were accurately able to identify 66% of targets within policy documents on these numerical representations. But I thought we could do much better. So I used a state-of-the-art NLP technique known as transfer learning. In transfer learning, you take a really complex model that's trained on enormous data, think the entire internet, and it's performed to do a specific task. And it does that really well. And in doing so, during the training process, it learns a lot of knowledge about the data that you have. So we can take the knowledge that this model has learned and combine it with our smaller domain-specific data set to fine-tune the model to perform a similar but slightly different task. The specific model I used was actually called BERT. BERT is trained on Wikipedia and tens of thousands of books to identify missing words within sentences, such as London is the blank of the UK. In this training process, BERT learns a lot about the way in which sentences and languages in general are constructed. So we can take this information and use it to improve the performance of identifying targets within policy documents. The overall pipeline I built for CPR then was identifying targets within documents as individual sentences and labeling them as such, manually curating these labels to make sure they are correct, and then training this very complex neural network model to predict targets within the documents. Then you iterate through this training loop to improve the quality of the labels and the performance of the neural network. Okay, so how did it perform? Well, BERT was able to accurately identify 72% of targets within the policy documents. That's 6% more than the baseline machine learning models, and that's a fantastic improvement because every little helps. So what impact will this have for Climate Policy Radar? Well, it will allow them to save policy analysts hundreds of hours because they would traditionally have to search through these documents manually by hand, and this can take months at a time. By aggregating targets from different nations together, they can map and track the global fight against climate change. And finally, it opens the floodgates for AI possibilities in identifying and tracking information within climate policy documents. Thank you very much.